Hello and welcome to Grade 3 Math Dive in 5, Unit 15, focused on quadrilaterals. I'm Daryl Frost.
And I'm Barbara Knox.
Welcome. In just a moment, you're going to pause this video and you're going to complete the task on the next slide on your own or with your grade level team or partner. Consider what tools a student might need to use to be successful with the task, and you might want to get those. I would encourage you to get those too, if you feel like there's a tool they might need for you to actually solve and go through the process. And then as you are working through the task, reflect on the 3 questions you see on the slide and record any questions that you think that would be really good as you plan for this unit.
See you back in a few minutes.
So let's take a look at the progression with BEST with geometric figures. Take a notice here what's happening in first grade. They're identifying, comparing, and sorting two and three-dimensional figures based on a limited set of figures which are listed there.
And I see there in that list that it includes not just polygons and three-dimensional figures, but it also includes like your circles and semicircles that
Exactly.
have curved edges.
And then in moving into second grade, they're identifying and drawing 2D figures based on defining attributes. Again, not just quadrilaterals, but other shape polygons as well.
And that list has just polygons in it. Now they are going to, if I look at that GR12 standard, they are going to be comparing whether or not the edges are curved or straight.
Yes.
But the defining attributes, it looks like, is going to be limited to the polygons.
To the polygons. And then in third grade, which is where we're focused today, MA3 GR12, it's identifying and drawing. What are we drawing? Identifying and drawing quadrilaterals based on their defining attributes. And the quadrilaterals include parallelograms, rhombi, rectangles, squares, and trapezoids, which is a difference between MAFS and BEST. And BEST, it specifically identifies those 5 quadrilaterals that they need to work with and be able to categorize and subcategorize.
Right.
And then looking at fourth and fifth, fourth grade is working with angles on and applying that to 2D figures. And then in fifth grade, it's subcategories of both quadrilaterals and triangles.
Right. And that triangle subcategories used to be in fourth grade.
Yes, exactly. So let's take a look here at student actions and vocabulary with this benchmark. On quadrilaterals, notice, Barbara, what are the actions they're having to do with quadrilaterals?
Well, they're having to sort them. They're identifying, drawing. They're going to be sorting in that process.
Yep. So identifying, drawing, and also sorting. And that vocabulary you see there, that's my word wall, and those words would be front and
And I
center.
really like the definitions that are used on this list because they're really the minimal definitions that you need.
Yes.
For example, rectangle. A rectangle contains 4 right angles. That's all I really need to know. Yes, they're going to have 2 pairs of opposite congruent sides, but any shape with any quadrilateral with 4 right angles is going to automatically have that.
This is kind of like a minimal defining definition of what it takes. This is the attribute that's necessary to categorize it as whichever type of quadrilateral. What do you notice about the trapezoid?
The definition is new for a lot of people, I believe, because this is the inclusive definition of trapezoid, which our new best standards use. And it states that a quadrilateral with at least 1 pair of parallel sides is a trapezoid. I think in the past, most teachers have used the exclusive definition that says trapezoids have exactly 1 pair of parallel sides, but in our new best standards definition, they have at least 1 pair of parallel sides, and we'll be exploring that again a little bit later.
And it'll make a big difference in how you categorize
yes,
shapes.
It will. Mm-hmm.
So Barbara, here is we're revisiting the task that all teachers solved at the beginning, and
Right.
this is a task that students in third grade would need to be able to do.
Yes.
So we're going to start with that first question there in the lower left. What questions could you ask as students are identifying the quadrilaterals?
Well, I would want to ask them, how do you know that these are quadrilaterals?
Okay, and then which ones are quadrilaterals there?
Hmm.
Which ones do you see are
So I'm going left to right on the top, the rectangle, the parallelogram, the trapezoid, and on the bottom, the rhombus and the trapezoid on the far right.
Yep, there you
So
go.
there are 5 of them
And why are those quadrilaterals?
because each one of those has 4 straight sides.
And that's the minimal defining definition for any quadrilateral. So they all
Mhm.
fit into that category. What challenges, misconceptions might a student have with this task?
They might just be counting sides and not whether those sides are curved or straight. So if I had a shape that had 3 straight sides and a curved side, they might say that that was a quadrilateral. Um,
Think about that circle. Might they do with that as a misconception? Would they think anything about it, or they say, oh, well, it's curved, so it doesn't have straight sides?
I would
No.
want them to say it's curved, and
Okay.
that can't be a quadrilateral because it has a curved side.
So
That
that's a
it's not
just
even a polygon.
so it's okay. So that's a way to justify why it's not
Hmm.
correct
Hmm.
in terms of being a
And I think too,
quadrilateral.
sometimes students count a side more than once. So if they're starting at a spot and they're counting around, for example, if I look at the hexagon, I might start at that top side and count 1, 2, 3, 4, 5, 6 as I go around, but I might not remember where I started and I might count the top again and say it has 7
Seven sides.
sides.
Yep. So begin and so that's also a connection to this is kind of abstract. Maybe
Mhm.
they need to build these
Build them or draw them and label the sides
sides.
or something where they know which sides they have been counted already.
What real world connections can students make to these quadrilaterals as they're
Oh,
exploring with
I'd be
them?
wanting to find things around my classroom, around the school that have those shapes. For example, a whiteboard is the shape of a rectangle, and I might have a trapezoid table in my room. If I do, I could point that out.
Or they could do a nature walk around
They could.
campus
Hmm.
and and have a sheet of okay, or identify, have them work in groups. Be a good thing for them to do to
Yep.
find those shapes and just be cognizant that those shapes are around their campus. We have a second task for you. In just a moment, once again, you'll pause the video, complete the task on the next slide. We're asking that you do draw representations that justify your answers. And once again, as you're working through the task, reflect on the 3 questions you see on the slide.
So we'll see you back in a few minutes.
Okay, so
Welcome
Barbara,
back.
yes, welcome back. So the task here was to determine which statements are correct. Again, explaining your reasoning, but we asked that everyone draw a figure to help support if the statement was correct or not correct or true or false or however you want to
So
think about
either a
it.
figure to justify that it is correct or one to justify that there is at least this one that doesn't fit.
Fit. So let's start with statement A. All squares and rectangles are parallelograms.
And
So
there, Daryl, I see a rectangle you've drawn that has 2 pairs of parallel sides, which is the definition of a parallelogram,
So that means that statement is
is
correct
true.
or true.
Yes.
All right,
I can't think of a rectangle or square that wouldn't be a parallelogram.
exactly. So statement B, you can go ahead and read that one.
A rhombus is a specific type of square. Here we have a non-example because the opposite sides are parallel, so it is a parallelogram, but it's missing those right angles, Daryl. So this one is not a square.
So that statement is false or incorrect.
Right?
But if we take a look at this,
That square is a rhombus because its four sides are congruent.
yes,
And it also has the right angles of the square. So if I change the words in statement B to say a square is a specific type of rhombus,
then that would be true.
then that would be true.
So
Right?
we really have to think about the language and the wording of the statement to determine if it's a category of another shape.
Correct. So that square is a rhombus with four right angles.
Yes. So a square is a specific type of rectangle. It absolutely is, because the minimal defining attribute of a rectangle is that it has four right angles.
And
And
all squares have four right angles.
angles. Have to think about that.
You do. All trapezoids are parallelograms. I can think of some trapezoids that are not parallelograms, as this shape that you just brought on the screen. It has one pair of parallel sides, but not a second one, and parallelograms have to have two.
That's the minimal defining attribute for a parallelogram.
Correct.
Two pairs of parallel sides. And so this statement D is false or not correct.
But again, Daryl, what if I change those words around to say all parallelograms are trapezoids?
Then that would be true, because with the inclusive definition, it says at least one pair of parallel sides for a trapezoid.
And all parallelograms have at least one pair of parallel sides because they all have two.
So statement E is true.
Statement E is true. That trapezoid does have two pairs of parallel sides. And again, this is that definition that might be new to a lot of you, and it's kind of hard to wrap your head around something that you
But it changes our
learned
answers.
one way, and now you're teaching it a different way. So
And it changes how we
it
categorize.
does.
So that's a good example of
There
that.
are two definitions of trapezoid, and with best standards, we're using the inclusive definition, which is that a trapezoid has at least one pair of parallel
Very
sides.
different.
Yep.
And then statement F, it is impossible for a quadrilateral to have no parallel sides. What do you think?
I'm wondering if they were able to draw one, Daryl.
Well,
I drew one. Did you?
I did.
Okay.
There it is.
So there you have
It's a quadrilateral.
It is a quadrilateral, but it has no parallel sides.
So that statement is incorrect or false, because you can, and there's an example of that.
Yes.
So hopefully everyone create that as well. But that's an important piece with students to experience and explore.
And I think we've talked about a lot of the misconceptions as we've been having this banter back and forth.
Yes.
Be expecting those misconceptions from your kids. Your children are in 5th grade, and they probably learned trapezoid with the exclusive definition. And now we're changing that thought process.
So categorizing shapes is a very difficult task for students. So here are misconceptions and obstacles, but I'm going to highlight there's 5, this 5th one here. Students may not recognize how one figure can belong in different subcategories. Well, our conversation on the previous slide just illustrated that, right?
It does. And here you're talking about the category of square,
which has the category of square, and it has different subcategories.
Right, I see a lot of them listed there: quadrilaterals, parallelograms, rectangles, trapezoids, and rhombi, and really polygon also. Right?
Exactly. So we need to think about that language of categories and subcategories. Here we have the category of a square and subcategories of
that square also fits into many other categories.
Quadrilaterals, parallelograms, rectangles, trapezoids, and rhombi. So here you see the CRA process with this benchmark here. It's really about building the quadrilaterals using tools such as anglegs, draw the quadrilaterals. Again, representation should be reasonably accurate. I want to put that there because that is a clarification within this benchmark. And then describe and compare quadrilaterals using all that academic language that we have discussed.
And there's a lot of it in this unit.
There's a lot of it in this unit and the last,
Yes.
and unit 14 as well. Okay, so this ends another Math Dive in 5 for grade 3. Thank you for joining us.
We'll see you back next time.